The new chapter is operational amplifier. In short, it is also called as a op-amp. OP as a operational, AMP as a amplifier. Op-amp. Op-amp is a full form is a operational amplifier. The op-amp is a high gain direct coupled differential amplifier. What is op-amp? Op-amp is a high gain direct coupled differential amplifier. Op-amp is available as a single integrated circuit package. Also, other definition is op-amp is available in the form of IC which perform the different mathematical operations such like your adder, subtractor, integrator and differentiator. By this op-amp IC we perform a different mathematical operation. That is your op-amp operational amplifier. You see the internal block diagram your operational amplifier. This is your symbol of operational amplifier. This is a symbol of operational amplifier or just name op-amp. You see here V2 is the positive terminal and V1 is your negative terminal and V output your output side of terminal. Also one of the point is also get suppose there is given at a VCC means positive is supply this one terminal and negative supply is this one. Overall this is your symbol of your op-amp operational amplifier. This symbol is internal block diagram of this one. The internal block diagram you see here. The first one is op-amp is a two-terminal device. One of the terminal is called inverting input and other is called non-inverting input. Means inverting input as a your negative terminal, which is this one, and positive terminal is your non-inverting. Overall, there is two terminal of op-amp. One of the called is inverting and second is called non-inverting. Okay, this input terminal now goes to input of your stage, input stage. Next to move this signal is intermediate stage and next to move your level shifting stage and last one is output stage. In the output stage we are taking the output. Whatever given input in this side we are getting output in the last terminal of your stage. You see here inverting and non-inverting as input. This is your input impedance input stage. In this input stage we use a differential amplifier. In this input stage we use a differential amplifier. Means this is your differential DA is your as a differential amplifier. Means this block is include a differential amplifier. In differential amplifier different types of available differential amplifier. In this input stage we use a dual input balance output. Means differential amplifiers such like your dual input balance output. And next to intermediate stage in this block we use a differential amplifier again. This is also use a differential amplifier in this block. What such like this is like your dual input unbalanced output. Means dual input, this is your dual input and balance output. Here you use dual input balance output, your input stage. This is also your differential amplifier. This is also your differential amplifier. Next is stage level shifting stage. In this stage we use a emitter follower circuit. In this stage we use a emitter follower circuit. Emitter follower circuit also called a common collector circuit. Output stage we use a complementary symmetric push-pull amplifier. Means in the output stage we use a push-pull amplifier. Which one is the complementary symmetric? And output is in the last stage we have considered. This is your symbol of op-amp. This is your internal blocks of your op-amp. Op-amp is a high gain direct coupled differential amplifier. Other form the definition is op-amp is a form of IC which perform a different mathematical operations such like your subtractor, addition, integrator and differentiator, etc. Now next to move your the property of your operational amplifier. You see here, first we discuss your ideal op-amp of property. Now there is a discuss here 7 property. This is your following electrical characteristic of your op-amp, ideal op-amp property. In this ideal op-amp property, the op-amp has a infinite voltage gain. Means ideal op-amp has a infinite voltage gain, and second is infinite input impedance, input resistance. Input resistance is infinite, and third is the zero output resistance, and fourth is the infinite bandwidth, and fifth is the infinite CMRR. CMRR also defined in the later stage. This is your common mode rejection ratio, and sixth one is the infinite slew rate, and last one is the zero output voltage when input voltage is applied 0. Okay, now expand this one. Infinite voltage gain means we already know the gain is the output upon input. Means whatever you input is provided, then gain is the ratio of output upon input. The infinite voltage gain depend your, suppose there is input is 0, then output is something, then if you divide the output upon input, then infinite is common. Means overall in the ideal op-amp, infinite voltage gain is the property of your ideal op-amp. Suppose if practical op-amp means which is practically possible of such like your circuit called as a practical. The practical op-amp means if the property is presented here, the property is practical op-amp is a very high voltage gain, and we consider a practical op-amp. We only here focus on ideal op-amp. Now go to next your upcoming your video lecture. We see your practical op-amp. You see here only ideal op-amp means infinite voltage gain. Second is the your infinite input resistance. Ri represent your infinite input resistance. Means what is the purpose of this one if infinite is present in your op-amp? If infinite input resistance is present, so that almost any signal can be drive it. There is no loading effect of your proceeding stage. This represent if any circuit has infinite input resistance, this represented as a any signal source can be driven by op-amp. This one is represented your infinite. Also this one is represented there is no loading effect if the previous stage is connected in this op-amp circuit. Overall we noted down infinite input resistance is the ideal op-amp property. And next one is the your zero output resistance. Means output resistance is 0. This represents so that output can drive an infinite number of devices. Means if op-amp is connected to other any devices, then this op-amp can drive the circuit. Means n number of devices connected in output side, this also drive. Means without any degradation of quality of your output, the proper functioning of your op-amp. Means zero output resistance property of this one. Means infinite bandwidth is represented. What is means so that any frequency signal from 0 to infinite hertz can be amplified without any attenuation. Means if any device such like your op-amp, if infinite bandwidth present, this represented if 0 hertz is amplified by this amplifier, 1 kilohertz is also amplified. This is dependent by your infinite bandwidth property. And next one is the infinite of CMRR, common mode rejection ratio. It's also represented so that the output common mode noise voltage is 0. Means between the common noise of the voltage is 0. Infinite CMR means the CMR value must greater than the which is possible in your practical circuit also. Overall conclusion is this one: infinite CMR is the better your op-amp. Infinite slew rate, this also represents the output voltage change occurs simultaneously without input voltage changes. With input, sorry, the output voltage occurs simultaneously with input voltage changes. Means if the input changes rapidly, also output is also changes. Means infinite slew rate represent whatever the input is changes, similar faster way output is also changes. This is represented as infinite slew rate. The next one is zero output voltage when input voltage zero. When op amp is apply a zero input signal, this also come here zero output. This one is 7. Overall conclusion of this ideal op amp, you noted down this one point: infinite voltage gain, infinite input resistance, zero output resistance, infinite bandwidth, infinite CMR, and infinite slew rate. Next one, zero output voltage when input is zero. You see here, there is the gain is infinite, Ri is infinite, and next bandwidth is infinite, and CMR is infinite, slew rate is infinite. Only output resistance is zero. If anyone asks you what is the voltage gain of your ideal, infinite. What is the input resistance, infinite. Means easily you remind your in a study. Okay, these are your ideal property of op amp. Next, move your equivalent circuit of op amp. You see here equivalent circuit of op amp. This is your internal diagram of op amp. This is Ri is the input resistance, R naught is your output resistance, and V1 and V2 is the input terminal of voltage, and V output is your output voltage. This is multiplied by V1 naught is equal to A VID. Means VID is the input difference between two terminals V1 and V2. This is represented as this relation.